Morning, everybody. We are from VMware Broadcom, and we thought we'd have a little bit of fun today. So anybody that's ever seen me present before knows that I like to just throw a little bit of fun in there as I go along as well, just to lighten the mood. So thank you for making the joke about the men in black suits, because you're actually spot on. That's the look we were going for today. We are the men in black. We want to start this off by saying and telling you, anybody know what this is on the screen? Can anyone call this out? Men in Black fans? Deneuralizer. Yes, exactly. Makes you forget everything you know. So what we want you to do right now is stare into the deneuralizer as we conveniently put our shades on so that we do not get affected by this. And we want you to forget everything you know about VMware and VMware software, because we are a different division inside of Broadcom. We are from the software-defined edge division, and we have reimagined what we've done at VMware to make sure that it fits the constraints that we see at the edge. Okay, so everybody's deneuralized. Everybody keep having a good life. I want you to be happy in your lives. Alistair, keep growing that mustache and wearing those shirts. They're great. Okay, we can take off our shades now. But really, who are we? We are, well, to start off with, am Alan Renouf. So I am a technical product manager at Broadcom. I work in the software-defined edge group right now. I've had a number of different roles at VMware. I started off talking about automation, specifically talking about Power CLI and how you can automate your data center using Power CLI. I then went into a product management role where I started taking requirements from customers around what they wanted to automate at their data center and how they wanted to automate it, and started working on APIs, SDKs, and CLIs. I then went into the office of the CTO and did some work on various different innovation projects. My most memorable moment at VMware was when I stood on stage with Pat Gelsinger inside of a VR headset at VMworld, and had him inside of a virtual data center, vMotioning virtual machines by throwing them at the cloud. It was great fun. Nothing came with the virtual data center. I'm still waiting for that to happen, but we'll get there one day. And now I work in the edge. Now I work in the software-defined edge. As I said, super great place to be in. Interesting place, if you ask me, the most interesting place in IT at the moment.
And I'm Chris Taylor. I run the product marketing department for VMware's edge computing and service provider product lines. And I started out my career actually in manufacturing. Started out as a mechanical engineer. And now that I'm working on edge, I'm dealing with some of the same issues that I saw way back when as a manufacturer. In fact, we're going to talk about virtualizing PLCs today, and PLCs haven't changed since I worked on them way back when. Now, after working in manufacturing, I switched into marketing, worked at software companies, VA Linux Systems, spent about 15 years at Trend Micro doing cybersecurity, and then came to VMware starting out with the SASE and SD-WAN solutions before moving into edge computing. And when we talk about the edge, it's really the need for a software-defined edge. And we define that as it's all the distributed digital infrastructure for running workloads across dispersed locations close to where that data is being produced. And so today we're going to be talking about edge computing and managing your infrastructure and applications at scale. But what this means is it's not just that. It's also all your security and networking services that you need to run those edge sites. And so that's where VMware, as a grader in our software-defined edge division, we offer more for the edge than just the edge computing. We have VeloCloud SD-WAN and SASE, and this ties in all your different edge sites and your data centers and your clouds and makes them all run faster and connect better, more reliably. We use a method called dynamic multipath optimization, which will make a single link run much better, or if you have dual networking links in different types like satellite and something else, it'll play off each other to make them run really great. And so we take the security and networking services that we offer and we pair them with edge compute. So this is our portfolio. And one thing you'll see on the right here is VMware Edge Cloud Orchestrator, which we're going to demonstrate today. And that's what we use to manage the edge compute and infrastructure at scale. But it shares the same console as running our intelligent overlay, which is the SD-WAN, networking, and the security services that we offer or that we partner with others for. And so the same console, and then we also offer a networking solution for telcos. And the idea in the future is that as the workload has different networking needs, the intelligent overlay will recognize the workload's needs and communicate that to the networking solution, your service provider, to adjust the network in real time.
Exactly. This is about providing that full stack that everybody needs at the edge. It's not just about the applications that are down there or the hosts, the servers that they might be running on. It's also about that network as well. If you have that complete picture of all the data that's at the edge, all the way from the sensors and the applications that are running there and the infrastructure that they're running on, as well as that network layer as well, you can really start to do some useful things with the data and optimize for what that edge location does.
Right, and so we're going to focus in on now edge computing for the rest of the talk today. And we see across industries, people are using edge computing at the edge, and the edge is where they're making their business operations. It's where they're selling goods. It's where they're producing goods at a factory. It's where they're offering services or producing electrical energy in some cases. So we see a number of use cases, and some of the verticals we're working closely with are manufacturing. We're working with new smart manufacturing and industrial 4.0 technologies where they're adding smarts to the manufacturing, like computer vision quality and control or predictive maintenance. But we're also helping manufacturers, we'll talk later at the end today, how they can virtualize their manufacturing floor with edge computing. In retail, we're seeing a number of use cases where they want to take the whole store infrastructure, and a retailer may have 20 apps in their store. Some may be on containers, some may be on traditional software like Windows, so you can virtualize them, running them together on a single server or single platform in that store. And some of the use cases we're seeing are also, computer vision to help prevent loss at the self-checkout and more. And in energy, we're helping electrical utilities virtualize electrical substations. And with energy, there's a lot of changes with energy and how energy is produced and consumed. So on the production side, you have much more alternative energy sources that are more cyclical in nature, like wind and solar. And on the demand side, now you have more EVs, electrical vehicles that need charging, plus you have rooftop solar, which is sending energy back through the grid, which it really wasn't designed for in the first place. So you have some instances where things are overheating. By virtualizing electrical substations, they can move much quicker. They can lower their operating costs, they can respond quicker to needs, and they can reduce their capital costs as well.
Exactly. These power substations have had this same equipment for 10 years, and it's the huge equipment that you see on TV when you think about a power substation. So really what they're looking to do is modernize what they've been doing for a long time. And I think now is a good time when they can actually start to do that, because they can really see the value in what we're doing around taking some off-the-shelf commodity hardware, clearly hardened for those areas and meeting the right regulations, but being placed into there and allowing them to develop and iterate a lot faster than they've ever done before. These machines, the utility stations, have often been there for 10 years and are still there running. So bringing them up to date really is great for that company, and it really does modernize everything that we need to do. And we're at a point where, let's face it, we need it, right? I mean, energy is changing a lot. Solar, wind, all these different energy types coming into the grid. They need to modernize to be able to take advantage of that kind of energy that's going in.
We're seeing opportunities at logistics and pretty much many other industries, other industries. Now, why would you put this compute at the edge instead of the cloud or your data center or some cloud service? So there's a couple reasons, and let's take the example of the loss prevention at the self-checkout. So we had a customer we worked with. they were finding on Friday nights, expensive bottles of wine were going missing. And, someone would take a cheap bottle of wine and an expensive bottle of wine. They scan the cheap bottle of wine twice and walk out with both bottles at a discount on the expensive bottles. And so they wrote an application to check what's being scanned. Is that actually being the item placed in the cart? And they could have put this in the cloud or the data center. They chose to do this at the edge because, one, it's a lot of data. If you're capturing video, it's a lot of data, and you only need a few snippets of that data. You don't just send that whole stream up to the cloud for analyzing it. Second is connectivity. So if there's any hiccups in your networks at the time when you're trying to prevent a theft, you may miss that opportunity. And then third is regulatory requirements. Now, this one didn't, but if you had a computer vision application that was capturing people's faces, then that's subject to additional privacy controls if you're going to send it off-site instead of deleting it right away.
Yeah, I remember meeting with a retail customer, and they initially went into the cloud, and then they did. That was until they hit their first snowstorm, and they realized, that kind of took out every network that we had to that store. And then suddenly the clock starts ticking for them, because I didn't know this, but after about 5 to 7 days, they start getting out of regulation with the price that they're actually selling things for. So without updates to their software regularly, they're suddenly out of compliance and they're out of regulation. So they need to find ways to do that. Clearly moving that locally, and as Chris said, moving that so that all of the data is generated locally, and only the interesting parts or the parts that you need to keep are kind of offloaded up into a data center or a cloud. That's when things start to get interesting. And that's where we see the edge in general. All of these verticals are really looking at the same things. They're looking to look at their data and monitor their data in ways that they've never done before, whether that is computer vision and a camera, whether that is sensors, whether that is a machine that they're attached to. They are all generating massive amounts of data. And if you can analyze that data, understand that data, and start to work with that data to get to a point where you can make things better because of that data, and then provide updates, that's really when you start to optimize.
Yeah, so along those lines, a lot of customers are looking at, how can they make those business operations run smarter? How can they use that data to make a quicker and smarter decision or provide a new experience? So some of the examples include retailers with a magic mirror where you could walk into a store, try an outfit, but then see it in the mirror in a different color. Or I've even seen examples where you can be walking past the store and a video display shows you walking past, but in a new outfit, enticing you to come in and buy that.
Wasn't that in the Minority Report?
I could have been. Yep.
Scans his retina, know who he is and what he bought previously, and then shows him something that he could be interested in.
Right.
Wow.
and then lots of using existing cameras that are in stores to do new use cases. So, for example, in the lower left there, you have the security camera that's in the top of the store of every grocery store you've been at. But you can use that also to track how are customers shopping through your store, and then can you optimize the store layout and the shelving. You can also use that same camera to see if someone spilled, a gallon of milk, and do you need to send somebody over to clean that up before someone else slips on it and sues you. And so it gives you a faster response to those type of items.
Yeah, I mean, let's face it, you guys, a lot of you have come from AI field day last week, right? So AI. AI is eating the world at the moment, and I think it's very relevant at the edge. There's a lot of great use cases that we can do. I don't know if you've all been into those retail stores and you've actually taken a look behind the scenes as to what's going on when you walk in the ones where you essentially pick up what you want, you put it in your basket, and then you walk out the door. I did that for the first time, I don't know, a couple of months ago. It felt like I was stealing, because you're so programmed to go to that checkout and talk to somebody and give them your details that, I don't know, it just felt weird. I was like edging out the door slowly. No pun intended, edging out the door. Okay, so but if you really look at what's going on in those stores and you take a look above you, you can see cameras everywhere. You can see servers up there as well, hosting these cameras, understanding what you are doing, monitoring you as a stick figure or as a person, basically what you're taking, what you're putting in your cart, what you're taking out of your cart. There's also sensors under some of the items as well. So as you take things off the shelf, It weighs the items that are left on there and knows what you've taken out, so it knows the quantity. They're using a number of different mechanisms to really understand exactly what you're doing in that store before you walk out there, so they can charge you exactly what you need. All of that requires compute.
Yeah, but Edge AI is different than the AI you have in your data center. Edge AI, it needs compute, but it needs smaller compute than you would have in your data center. You can't have a large language model easily at an edge site, but maybe you can have a small language model or something optimized for that. And really the difference between Edge AI and AI in your data center is that it's interacting with the physical world, with cameras, with sensors, to make a smarter decision. So despite the promise of AI and all that it offers at the edge, a lot of AI projects like in manufacturing, they call it Industry 4.0 or smart manufacturing, where they're taking sensor data from the manufacturing slide and manufacturing and making it smarter. A lot of these projects fail to get past the pilot phase because it's difficult to manage edge computing at scale and keep all your applications up to date. And so, it's different than the data center. In the data center, where most of IT people have their roots, you may have 1,000 computers at a few different sites. But the edge, you may have 1,000 sites with a single server at each one. And so the challenge of scale is completely flip-flop from what you have in the data center.
Yeah, absolutely. I mean, these are the key areas that you need to design for, and working as a product manager, these are the key areas and fundamental areas that we used to redesign our system to make sure that it worked at an edge location. When you're talking about scale, you're not talking about putting another server in a rack in a data center. You're talking about scale of sites, like hundreds or thousands of different sites. And as Chris said, this compute in those environments might be completely different. It might be completely valid to bring something like a small form factor PC, which we have here, and then if it goes wrong, throw it away and put another one in, because it might be cheaper to do that than provide resiliency. So the edge is completely different when we talk about scale. Networking, obviously, again, completely different. You've got to design for the fact that that network might not be there. What happens if it's not there? How can I keep running? In occasions where we're talking about really offline edge environments in the military, they're literally jumping out of planes with small servers in their backpacks. They need to provide services at the edge of the field. They're probably not going to have network connectivity for a long time. So you need to make sure those applications are up and running, that everything's working, and that it's very easy to build those, deploy those, and provide the entire system that they need out there. Otherwise, you're literally causing loss of life.
Yeah, and in addition to network connectivity, you may have private networks where you don't allow inbound connections, or you take your network offline. We had a food producer who, during their production runs of 24 hours, they would shut down the network completely during that time to preserve the integrity of their food they were producing. And then edge hardware and protocols. So you may have ruggedized servers in your steel plant that you need to provide services on. You may have industrial protocols like Profinet to connect different PLCs and different equipment at the edge. And plus, if you're doing AI like computer vision applications, you may have some retail stores with a certain model computer, another one with a better model computer with separate graphics. And so you need to be able to have those edge applications run at both instances and manage the different hardware at those instances.
Hey, Chris, quick question, just make sure everybody's on the same page. What is PLC?
Oh, sorry. PLC is a programmable logic controller.
Thank you.
And it's used in manufacturing to provide motion control or to make decisions, simple decisions. You see this sensor, then you turn on this valve. And so it's like a mini computer. It's about a little bit bigger than this. It's really old technology, though. So when I started in manufacturing, programmable logic controllers were pretty much the exact same as they are today. The only difference is now that the color is different and maybe it has a USB drive on it now. And we'll talk about it in the final section today about how we can virtualize those. And you need to do all this with often limited on-site personnel who are trained in, how to run a server. In the military example, the guy jumping off the plane, doesn't know how to update the applications. He just knows how to use it. You may retail stores. You have 10,000 retail stores. You don't have an IT person at each one to install updates, et cetera. And so we need to be able to deploy and manage all the applications and infrastructure without on-site personnel. And then finally, security is different. So you have a typical security systems concerns of any IT system of cyber risk, but you also have more physical risks. So, you've probably been in a restaurant and you walk to the restroom and you see the server for that restaurant in the hallway. And so servers in retail stores are often in the back room. They may be under the counter. So they don't have the layers of security that you have in a data center.
Yeah, that's also where the hardware comes in as well. Like you were talking about manufacturing, they use a lot of industrial PCs, and these are servers that essentially don't have fans in them. They have the heat sinks on them, so it makes sure that while you're producing something on a manufacturing line, you're not ingesting the bits that maybe are cut off from the welding machine or something like that, right? These are great machines that are ruggedized for the edge, and we see a lot of different hardware coming into the edge now and being made available, and different architecture types being made available for the edge. So we've started to work with those vendors and make sure that we are providing exactly what's needed to work with those types of hardware as well.
Chris and Alan, can I touch back on the first two items here?
Yeah,
so
sure.
If one thing I've been struggling a little bit trying to understand is, and I know you're going to get to it, what's getting virtualized here? I mean,
okay.
So if I'm thinking of the scale problem, if I understand it right, and tell me if I don't, we have limited resources to distribute the virtualization, so to speak, and they need to be, they are necessarily potentially fragile, and so the range with which you don't have the same scale. It's a limited scale question. You don't have the same scale of resources to provide the same service levels that you normally would. Is that
so I think you're pointing out that you don't have like a big stack of servers to run these applications.
Yeah, you can't just add a server or
you can't just add, right.
The cluster is going to be small, or
right.
if not vanishingly small by comparison.
It's often single node or maybe a few nodes.
Because it seems it's counter to the whole idea, I think, that you have many edge locations and you're somehow virtualizing across them when locality is part of the whole idea. But within each site or location, you may have limited resources to work with. And by the same token, the network limitations may limit the scope of how or across, what boundaries within which you can do that resource sharing. Yeah.
What we're talking about is like virtualizing the applications within, say, a store. So a retail store may have 20 applications running in there. So point of sale, maybe they have a computer vision system, security system, something with inventory, and a smaller store maybe only has a few applications. And we're virtualizing those applications that need to run close to where the data is being produced. Today, what we're often seeing is on the left is they have a few different servers. Manufacturing, it's a single function server for every every function in the manufacturing environment.
How are you making that data you've talked about, the loss of connectivity, you've talked about,
let me go back.
Small subset of hardware in those situations. How are you making that data resilient so that, if you have that long loss of connectivity, you have that hardware issue, that all that you have there is lost? Is there a synchronization back or an upstream, like polling that then happens?
Yeah, so I think it's interesting. You're both kind of coming from different ends of the scale right now. So somebody's saying like, hey, we need these small servers that are really small. And then somebody else saying, hey, we need resiliency for the data. So this is exactly what we see. And this is why I love the edge, right? We see a different thing at every single person that I talk to. But there's a lot of commonalities as well. As Chris said on this next slide, right, we see a lot of people going in with POCs for a particular use case. I want to run this one computer vision application that monitors the people that come into the store, and if they're a bad actor, I can basically, tell people in the store, go careful, there's somebody in here that we don't want to interact with. That's great. And then the next person, the next team We'll bring another server in, and they'll run a different computer vision app, or they'll run a point of sale app, or they'll run a sensor monitoring app. Suddenly you start to get that sprawl that we saw in the data center at the edge.
Yeah.
And those are the kind of applications that we're initially looking at. We're working with customers. I mean, we're in this mixed world of containers and still legacy applications. I say legacy applications, they're still not legacy to a lot of people. They are applications that run inside of virtual machines. They're applications that have been there for 10 years and they can't replace because they still need it. So we're seeing exactly the same things that we saw in the data center, but now at the edge. So providing those, there's some similar resiliency that you're probably used to, a vSAN cluster to provide that data resiliency where it's needed. But in other customers, where they need smaller servers, perhaps we just give them an endpoint. Perhaps we give them a very small layer that allows them to monitor that layer, understand what's going on with the applications and the infrastructure, and then update those applications in the infrastructure as well. So really, this is a mixed bag of different type of architectures. And I can't tell you there's one solution to this, because it really does come down to the customer requirements, what they need. And then we sit with them and we work out the architecture of how this works. Hopefully you'll see some of the changes, certainly when I do the demonstration later on, that will show you how we've started out on a single node server with our orchestration. And we're moving into clusters right now. But you will start to see how it all comes together. But both great questions. Hopefully I answered those.
Are you reaching down into the application layer and providing libraries that work better with your systems for the resiliency and perhaps, network dropouts and things like that, so that you can have unexpected network outages, have things keep working, and the synchronization just continues on at the application layer? Or is that something that somebody else has to build into to run on top of your system?
Again, I think it's a combination of things. For example, when Chris goes through the manufacturing, we'll talk about the work that we've done on a low latency virtual switch that supports some of those things that are needed in manufacturing. Actually, inside of the application, I think there's a lot of data that, first of all, we can gather from outside of the application. If you think about it, if you provide an SD-WAN device, we know what's going on the network, so what that traffic is coming from that application. Through the virtualization layer, we probably know more about what's going on with the disk, the CPU, the memory, everything that it's doing outside of that. Inside, I'd love to get to that point where we can analyze inside of the actual applications as well and provide you that intelligence. I see that as a long roadmap item. And I think what we need to do, first of all, is start to understand what are those common applications out there at the edge that we need to start doing that with.
Yeah, as Alan said, a lot of customers are looking at just this one use case I want to solve and not the big picture of what's my edge strategy going to be. But one of the customers who has been more proactive in this is Audi Automobile. And we've been working with them, and they started looking at all the Industry 4.0 technologies they wanted to add to their factory. So, for example, they're adding machine learning to their welding robots. So it's more repeatable, and they don't have to then take as many samples offline to do X-ray inspection of the welds. And then they're also adding machine learning to all the torque wrenches that the assemblers use. And they started looking at this, and managing compute today is really difficult in a factory. The way that updates are made today is a technician goes out with a USB drive during the production breaks and makes a quick update. And if you need to do a Windows restart, that can take weeks sometimes to do an update. And Audi looked across this and said, we'll be adding more and more compute into our infrastructure, and that's going to cause a maintenance nightmare if we don't do something different. So they really went in with a plan on, okay, we want to add more compute, how are we going to manage this? And so we want to help customers get from that pilot phase past the initial deployment to massive deployment across thousands of sites. So really they can focus on what they're trying to do with those applications. And to do that, we need a little bit different approach than we do with traditional IT management systems. Traditional IT management works with a push mode approach, where you push down updates, the management layer manages multiple API transactions, and it's managing the state of each of those transactions and the edge. So it's a lot of network traffic going back and forth. if you have network hiccups and massive scale, it becomes difficult to manage. But it does work really well in a controlled environment like a data center. So instead, we moved to a pull mode approach. And with this, it's kind of like updating your iPhone. Your iPhone, sees that it updates, pulls it down, installs it when you're sleeping. And with this, the edges check in, see if there's any updates, and they pull down the additional components they need to reach a desired state. So it's using a GitOps and desired state methodology, which works really well when you have the scale that we're talking about with edge sites. And I kind of think of it as you need more independence for your edges. And when my son went off to college, it was much different than when he was in 7th grade, getting him ready for school. So getting ready for school in 7th grade was like, Zach, did you brush your teeth? Did you do your homework, etc. Now he's away to college, and he needs to act independently regardless of my management. And if he doesn't brush his teeth, well, good luck getting the date. If he doesn't do a homework, then he may fail out of school.
Nice.
So what we offer with VMware Edge Compute Stack is an edge optimized and runtime and orchestration platform to help manage this edge at scale with limited resources. And so, it uses the management method that we'll talk about today, the orchestrator, with that pull mode architecture, to make it very simple to deploy without IT staff at the retail site or the factory, and also to keep all those applications up to date. The runtime is based on VMware ESXi, which is great because it has that throughput, not throughput,
Real-time.
the proven is what I was looking for. Proven, we have 7 million estimated edge workloads already running today. And when OT people look for something that's going to control something reliably and repeatably in the factory, they want something that's proven. And so it can run with virtual machines and Kubernetes, including real-time apps. And then it's very flexible. So, your needs are going to change. You're going to plan what you think you need in the next few years for edge computing, but it's probably going to change because edge AI and the whole AI industry is changing so quickly that in a few years, you're going to need something different. So it's expandable. You can change it. You can add to it as your needs change.
So Chris, in that whole thing, where does security fit in? Does it fit in as a multi-layered security? Like you guys have got the localized SASE secured by Symantec. What's the level of integration? What about third-party products that already exist? How does security fit into your model?
I think security needs to be at every layer, honestly.
Yeah.
Even from the point of deployment. So I'll go on a slight tangent here for a second, if you don't mind.
Mm-hmm.
But when I was talking to a customer, they were talking about secure root of trust, and they talked to me about how they deliver their sites to their location at the moment. So they'll ring a hardware vendor and they'll say, I want 100 of these servers and I want them delivered to these sites. They don't know in between the actual delivery point, if somebody's got hold of that server and injected it with something, I don't know, some new chip or some hacking capabilities, that when they plug it in and then build that server out, suddenly, they are not secure. So they want secure root of trust all the way from the manufacturing point of view. So security needs to start even before that server is shipped out there. And then once it's on there, you're right, every single layer that we add on top of that needs to be secure, whether it's the virtualization layer, taking capability of looking at the customer certifications and making sure that everything that runs on there is authorized to do so, whether it's the Kubernetes layer running those applications on top of that, or whether it's the networking as well. So I see security as intrinsic throughout the entire platform that we need to develop. And there'll be multiple different areas in which we provide that.
And then as far as your question on the integration with localized, SD-WAN, and the security services, so the VMware Edge Cloud Orchestrator, which provides this edge management for applications and infrastructure, also manages the SD-WAN and security. So it's just different tabs within the management console. And then if you can run those security services as a virtual machine or a container, you can run them in the Edge Compute Stack as well.
And what about the integration with third-party security services that might already be out there?
Yeah, I mean, it's necessary. We will provide integration with those as needed. Again, multi-layered, so in every part of the stack, we're looking at integrating those. Whether it's a third-party certificate vendor or whether it's a secure way to provide secrets, all of these things are constantly on things that we're looking at.
So you say you're looking at, does that mean it's a future, or do you have something at the moment?
Yeah, the orchestration layer as it stands at the moment doesn't have integration with some of those. I mean, hey, my product's never done. I love to keep adding to my product. So certainly some of those areas are future. Other areas we've built from the foundation up.
Since we're talking about management at the moment, I want to forward on a question from a friend of the program, Gina Minks, who's asking about, you're showing single edge node or 2-node cluster type situations. The messaging from VMware at large is VCF is everything and everything is VCF. How does this play into that conversation?
Remember when we shone that light at the start and told you? I guess it didn't work with the people online. So we're not from the VCF organization. I completely understand the messaging from that point of view. But what we're providing is from the software-defined edge group. So we are taking advantage of some of the items that are there already inside of VeloCloud and inside of the SD-WAN devices. Some of the principles that they've used for a long time. Like if you think about some of the things that we've been talking about around having a server delivered to site, powering it on, and then registering it, and then suddenly it gets all its applications and everything works. That's what an SD-WAN device does.
Okay.
Simple to deploy, simple to push out. So we're an individual division within Broadcom and VMware. We have our own licensing structure. We have our own go-to-markets. But we obviously, take advantage of some of those core features that are there already. And some of those features are part of the VCF stack as well.
Okay.
So, Alan, you said you have your own licensing structure. Does that mean the Broadcom changes to the ESXi licensing something you?
I knew I shouldn't have mentioned licensing.
Yeah, maybe we.
As soon as it came out of my mouth. Yeah, no, let's just not go there. Yeah, Chris, do you want to do a better job than I will about talking about licensing?
It is different, and we're not really involved with the VCF license on how they're doing.
I was just thinking that the single node ESXi is not Broadcom's favorite way of selling ESXi, but I guess in your scenario, you're selling hundreds and thousands of single nodes or small clusters.
Absolutely.
We're designed differently. We're designed, it's optimized for pricing at edges, not for pricing at the data center.
Yeah. No, we can definitely provide more details on licensing, honestly.
Let's not go down that rabbit hole. Let's.
Okay, in just a minute, Alan's going to do a deep dive in the architecture and do a demo, but I just wanted to give you the high-level marketing view. There's two major components, actually three if you count the edge agent. There's the runtime, which is an optimized EXI and Kubernetes runtime designed for the edge constraints like single node. And then there's the optimized orchestration, which we're going to talk about, which allows you to do zero-touch operations. Now, as Alan mentioned, we took some of the knowledge that we have from deploying SD-WAN systems. So VeloCloud, 10, 15 years ago, developed this zero-touch provisioning that was, breakthrough at the time, but we've learned a lot over the years on how to do that really well, and we're applying a lot of that knowledge here. And so, when you're going out and say you're a retail store deploying, 10,000 new edges, first thing you do is your edge admin's going to pre-configure the edge sites and authorization and a profile. And then he's going to add all the workloads that they need to the desired state repository. And the OEM or the system integrator or yourself can install a basic VMware Edge Compute Stack runtime on the server. And then when it gets shipped out, a non-IT person, say in a retail store, the store manager, can follow some basic instructions on how to plug in the server and how to establish a network connection. And then the server is going to self-configure itself. And it's going to look at the desired state repository, see what I need to install, download all the components it needs. And then on an ongoing basis, then your edge admin maintains that Git repository updates components, and then your edges will check in and pull down the updates when they need to make a change.
So I think this is super important. This was certainly one of the early revelations to me when I met with our customers and I started interviewing them about the problems that they had at the edge. I remember sitting with one of our customers who was an oil and gas company, and I said to them, okay, what are your problems? And they said, well, building out, we can't scale fast enough. We know we have hundreds, thousands of sites that we need to be in, but this is what it takes at the moment for us to build a cluster or a server. First of all, we have a 60-page document. We have to take that 60-page document and give it to a service integrator. The service integrator builds that equipment out for us following that document. And then they deliver that back to us so that we can then take that equipment, put it on a helicopter, fly it out to an oil rig, plug it in, and hope everything was configured correctly and it comes up. The problem with that is, there's a lot of problems with that, by the way. But the problem with that is they can't scale fast enough because this is, to them, a 3-month process to set up one edge site, or a lot of money to get that system integrator to do this time and time again. And they get manual errors with this as well. So the system integrator has turnover of staff. They might have somebody that does things great, and then they might have another person that makes an error. And then guess what? If it goes wrong when it's on that edge location, somebody's got to jump back in that helicopter, fly out to that edge location and fix that again. So like zero-touch provisioning really eliminates a lot of those issues and allows our customers to scale as fast as they can. Plugging the server in, and I will give you, hopefully, a live demonstration of this today. I have a video backup in case it goes wrong. But I will show you a live presentation where I've literally plugged the USB key into a server. We're gonna bring it up, and I'm going to show you how we can deploy a computer vision app and a billboard type application, which is attached to the server, to show you how quick it is for us to be able to do this.
Well, question about the time frame of that, right? If we're moving these devices from a pre-configured state to somewhere at an oil rig in your example, is there a time delta where that device that's in a box somewhere I can no longer hook that up and it work, right? I don't want something sitting in a warehouse for 3 months and then it can actually come online and join my network.
Yeah, that's interesting. And again, it changes for each of our customers. So I'm working with a company at the moment where they are building such large manufacturing lines, and the IPC is part of that, that it takes around a year for them to ship that equipment from their location to another country and it to be powered on. So they definitely have time constraints there. They want to make sure that in a year's time, those certs haven't run out. I can still communicate with the system.
Right.
All of this stuff basically comes on and still works. So yeah, that's part of what we're designing, yes.
It's a lot of certificate management at that point.
Yes, a lot of certificate management. Yeah, and other areas that you just wouldn't think about. Yeah, great question.
So just to wrap up, and then he's going to go into the deeper dive technical and demo. So 3 key things. We're edge optimized to run critical workloads at the edge. We're simplifying operations to scale it using zero touch, and it's a very flexible platform. So we talked to a lot of customers. They have new applications on containers, but they have all their existing applications on virtual machines, and we can run both of them well equally and keep them up to date.